Thank you, Uni, for the invitation and the possibility to talk about OPC UA Cloud, empowering central data modeling on the OPC Day in Finland. First things first, my name is Biene. I'm the CEO from Inray, the company behind the OPC router. You can find me on LinkedIn, and as Biene is the German word for a bee, you will find me on GitHub like this. I'd like to invite you all to join me into my virtual time machine and recap some great moments for me as a data connector. First, let's jump back into history, into the pre-OPC era, and take a quick look at the great evolution of industrial communication. We move fast through the time and are approaching the present time where we take a look at the great work on domain-specific information models. Up next, we will see the power of the OPC UA Cloud library as central repository for information models and glide together further into the future and look at solutions in the cloud-to-cloud communication. Last but not least, I would like to give you a glimpse into my own personal crystal ball for the future. A long time ago, there was a time called the pre-OPC era. Just to remind you, we are looking at the past through the eyes of an industrial data connector. We'd like to develop an application to connect to different devices. To achieve that, we have to deal with a lot of proprietary protocols. We need to read a lot of documentation, specifications, and manuals. And if we are not able to find any specifications or documentation, we need to reverse engineer the protocol by ourselves. This leads to a very complicated application development and integration process. With the rise of the OPC era, this issue got solved. Industrial device and component vendors were able to provide an OPC server for applications to connect to. These OPC servers would then translate the proprietary protocols to the OPC standard. In addition, there are several companies that implement OPC servers for devices for which there are no OPC server from the device vendor itself. Besides these advantages, OPC enables far more, for example, push notifications for value changes and self-describing interfaces via node browsing. Which leads us to a more simplified application development and integration process. However, not everything about the first version of the OPC standard, today also called OPC Classic, is perfect. It relies massively on Windows technologies and does not allow complex data types or semantic models. Especially the foundation based on Windows COM is an enormous challenge in practice. As soon as the OPC server is to be connected through Ethernet via another system, the configuration becomes hell. We call it the DCOM hell. To achieve this, it gets even worse if we want to connect through a firewall. To achieve this, we literally have to open up the entire firewall. This is where OPC UA comes in to solve all this and so much more. I like just to name some of them. Local host equals to remote host. So there's no difference in between connecting from an OPC client to a local OPC server instance or to a remote instance. It is platform independent, so it runs on Windows, on Linux devices, and connection through a firewall is easy, it's just opening up one port. It is secure by design, certificates, ensures authentication and authorizations. Besides that, OPC UA provides the capability to create complex data types, entities, events, and method calls, and so on, so you are able to design your semantic data model. Thanks to the fact that OPC UA can run on various platforms, more and more device vendors implement an OPC interface directly into the devices. So we are able to integrate, for example, QR code readers into our application, barcode readers, even barcode readers from different vendors, and RFID readers. But as they all have their own vendor-specific data model, it gets a high configuration effort to implement all these different devices. This is where the power of the companion specifications comes in place. Thanks to the OPC UA Auto ID companion specifications, this example, device vendors are able to harmonize this. So from my application point of view, there's no difference in connecting to a reader from one vendor or the other. These and many other companion specifications are provided by so-called joint working groups in which the OPC Foundation works together with the industry, associations and companies. Experts from all over the world create in working groups domain-specific data models. Many joint working groups has released initial versions or already extended versions. And the feedback of these release candidates and releases gets integrated in the following versions. And the fast adoption seen by many companion specifications in the industry, like with the Auto ID or the Euromap, it gets clear that the world was waiting for these standards. These companion specifications developed by the joint working groups can then be published with various tools to the OPC UA Cloud library. The OPC UA Cloud library provides a machine-readable interface for applications to create an UI to browse through the collection of the companion specification and data models. It gives a machine-readable access to the data models stored in the UA Cloud library, which provides the capability to link data fragments to a specific entity in a data model stored in the cloud library. Via the GraphQL interface, it is possible to browse into the data models. It is possible to search for data models and much more. You can think of the OPC UA Cloud library as central repository for the data models. It can either be used, the public hosted instance by the OPC Foundation, or it can be hosted on your own, either as public or private instance. Working groups and company-owned data models can be published to the cloud library. On the other side, we have OPC UA servers implementing these data models and bringing the data models to life. Then, various applications can either use these data models via connecting directly to the OPC UA servers or via accessing the UA Cloud library, which provides us the possibility to use OPC UA PubSub to publish data and share the same semantic data model in the shop floor and on the cloud. It's getting more and more common that component suppliers and device vendors provide cloud-based solutions for the product. And the clouds are able, with help of the OPC UA Cloud library, to interpret the semantic information of the received data. We can even use PubSub or a proprietary MQTT link between clouds to transfer the semantic data from cloud to cloud. And each cloud portion will be able to interpret the semantic data via the link to the OPC UA Cloud library. And the cloud applications can then do like analytics, data processing, alerting, and so on. The OPC UA Cloud Federation working group is working on standardizing this cloud-to-cloud communication. Here, special solutions for more secure and generic coupling between individual cloud applications are worked out. So the OPC UA Cloud library then is the basis for the common information models between the cloud applications. So finally, I would like to share some thoughts on currently common problems. Production downtime due to development and implementation is considered as necessary evil. Automation engineers need, for testing and implementation, access to the production. Reconfiguration of devices and components needs to be properly documented and be in sync with the configuration of various other systems. This leads to the fact that in a typical production environment exist many systems that are dependent on each other, and not only on the data, but also on the concrete configuration. In the IT, there is a solution to solve this, to store the application data and the application configuration together in a central versioned place, in a version control system commonly used, Git. And from there, in the IT, it is common to use automated process to deploy this configuration to, for example, a lab testing environment, where we can use virtualized systems and stripped down systems to test our application changes. And we can implement some QA processes to approve these changes. And as soon as these QA processes are succeeded, we can then apply our changes to our production line, and if this integration succeeds, we can wrong button? Okay. Sorry.
It was a simulation of downtime.
Simulation of downtime, exactly. So if it's succeeded, we can then deploy it to the other production lines. This provides us the possibility to do, in case of it is not successful, do a fast rollback, because we have a versioned state in our version control system, if the environment follows the version control system. If you do automated processes, we can use the Git, the version control system, as desired state. It's single source of truth. We have automated processes to deploy our versioned application state, configuration state, to either lab testing or production environments. This brings us to the possibility to use Git, like branching model from Git, use a development branch, use a QA integration branch, and use a production branch. So the development process is done on the development branch. As soon as the development is completed, we can do a merge on the QA and integration branch. And the QA environment is automatically updating to the desired state on the QA branch. And as soon as the lab testing is completed, we can then merge our changes to the production branch and then validate in the first step and roll it out to other production systems. What we need for that is to do the configuration by files or by remote controlled systems. So we can integrate automated processes for configuration and management for each single components we use. A recap: OPC Classic as basis for standardized communication, which got superseded by the OPC UA, which provides us interoperability, complex data types, and the possibility for data modeling. And the OPC UA Companion Specifications, which provides us pre-built domain-specific information models. And then the OPC UA Cloud, which provides us standardized access to these companion specifications and the possibility for semantic data in cloud-to-cloud communication. And DevOps, my private wish is to have the possibility to specify the desired state in code for versioned environments, and which then leads us to the semantics for environments. That's that from my side. Thank you. And next talk is Matthias Damm with the latest news of OPC UA PubSub.